Hey, in this video we're going to derive something called the quotient rule. Now, quotient is another word for fraction. So quotient means fraction. Now, what this rule says is that for a function y of x that can actually be written as another function f of x divided by another function g of x. Obviously, g of x can't be equal to 0 on the interval you're concerned with. So if y of x equals f of x divided by g of x for some functions f of x and g of x, then y prime of x is equal to f prime of x times g of x minus f of x times g prime of x divided by g prime of x, no, not g prime of x, divided by g of x squared. So in other words, differentiate the top one, leave the bottom one alone, minus, leave the top one alone, differentiate the bottom one, and then square the bottom one and divide. So that's called the quotient rule. It's called the quotient rule, and we're going to prove that right now. So to begin, let's suppose that y of x does in fact equal f of x divided by g of x, and that g of x does not equal 0. Well, this can be written another way. This can be written as f of x times g of x to the power of -1. Remember, negative power means you're dividing because you're canceling stuff off. Because if you've got a to the power of 3 times a to the -2, we know that's equal to a to the power of 1, which means we've actually divided away 2 of the a's. We've actually divided away 2 of the a's to get a to the power of 1. So, to the power of -1 actually means you're dividing by g of x. So, that's all good. Now we're just going to use the chain rule. So to do that, let's take care of this guy right here in the circle. So suppose that z of x is equal to u of g of x, which is equal to g of x to the -1. Well, then in this case, it must be the case that u of g is equal to g to the -1. Otherwise, there's no other way to write z of x as a combination of these functions. So u of g equals g to the -1. Then we know from the chain rule that z prime of x, if we differentiate, in other words, if we differentiate this thing with respect to x, then it's equal to u prime, so u differentiated at the point g of x, times g differentiated at the point of x. And so, well, u differentiated, u prime of g, well, we bring the power down, subtract 1, so it's going to be equal to -1 times g to the power of -2. So in other words, negative g to the -2, and written a different way, this is equal to -1 divided by g squared. And therefore u prime of g of x is equal to -1 divided by g of x squared. And so z prime of x is actually equal to negative g prime of x divided by g of x squared. So in other words, the derivative of this thing in the circle is equal to negative g prime of x, because it's equal to -1 times g prime of x divided by g of x squared. Okay, and obviously f of x is just, when you differentiate f of x, we can just write that as f prime of x. So, oops. We have that if y of x equals f of x times g of x to the power of -1, we have that I better write that, y of x equals f of x times g of x to the negative 1. The product rule says that y prime of x is equal to, first we differentiate this thing and leave the other one alone. So f prime of x times g of x to the negative 1. Well, g of x to the negative 1 is just a different way of writing divided by g of x. So that's all good. Plus, now we leave the first one alone. We leave f of x alone and we differentiate g of x to the negative 1. Well, we already did that on the other page. And so we found that if we leave f of x alone, so leaving f of x alone, we found that on the other page when we differentiate g of x to the negative 1, we actually get times negative g prime of x divided by g of x squared. G of x squared. So this whole thing now is equal to f prime of x divided by g of x minus f of x times g prime of x divided by g of x squared. And so now we would like to write it as one fraction, and there's a really nice easy way to do this because g of x divided by g of x is 1. So we can actually just go ahead and times this guy right here by g of x divided by g of x, and then it's still the same thing because g of x divided by g of x is 1. So we're just timesing f prime of x divided by g of x by 1. So it's still f prime of x divided by g of x, but it now allows us to write the whole thing as a single fraction. We get f prime of x times g of x divided by g of x squared minus f of x times g prime of x divided by g of x squared, and we can write this as a single fraction, which was in fact the whole point of doing that. So we can write this as f prime of x times g of x minus f of x times g prime of x divided by g of x squared. So when you have y of x equals a function f of x divided by another function g of x, where both of these are differentiable and obviously g of x can't be 0 anywhere, then the derivative, to find the derivative, you first differentiate the top one, leave the bottom one alone, and then you leave the top one alone and differentiate the bottom one, subtract, and then divide by the bottom one squared. And this is called the quotient rule. That's it for this video. Thanks very much for watching. Don't forget to check out the notes and have a go at the exercises. Take care. Bye.